Taylor polynomials. Okay, so on the next slide, I'll introduce what this is about. So let's say we have some graph. Oh, wow, that was really bad. Okay, so there we go. That's better. So we have our x and our y. And let's say we have some curve that looks like that. Okay, so this is our f of x. Alright, so this is the curve we're trying to approximate. And remember how when we did linear approximation, we would take the tangent line, right? Tangent to the curve. Okay, hold on. Trying very hard to make this straight. Okay, that was pretty good. So this was like our L of x, right? Remember linear approximation? So now what we're going to be doing is different, I guess you can call them degrees of approximation. So this was like the linear one. That's like another way to write our Taylor. That's what the T stands for. Taylor approximation of n equals 1. Okay, so n is your degree or your level of approximation. So what T2 would look like is basically going to be like something like that or something. So see how it's closer to the actual shape of f of x? So this is like our T2. And this is going to look like some kind of parabola. And you'll see why in the formula that I show you later. But and then let's say you have T3 next. T3 would be like an S shape. Okay, because that'll be a cubic. But it's getting closer and closer, okay, to our f of x. That's the whole concept. So anyways, what a Taylor polynomial is kind of like an approximation to the n, I guess, degree. I don't know what you want to call it. But basically, as n increases, the approximation gets closer. So the approximation gets closer to actual function, to your actual f of x. Okay? So I'll write the formula in the next slide. It's kind of long. Well, not that long, but yeah. So Tn of x equals what's called f of a plus f prime of a over 1 factorial, x minus a to the 1, plus f double prime of a over 2 factorial times x minus a to the second, plus dot dot dot, and you just keep going until you get to f to the n of a over n factorial times x minus a to the n. Alright, so this might look complicated and you're like, what's going on here? I don't really understand why we're doing this and what it's doing. So first of all, I guess for some terminology, so the a, that's what the approximation or the Taylor polynomial is centered at. So centered at a. And then in the problems, in the homework and stuff, they'll tell you where it's centered, so you don't have to worry about that. So this is your a, and then x here, so x here, everywhere you see an x, that's what the value that you're approximating. So value you're approximating. Okay, and then our function. So this would be our original function, right? And f prime of a, that's our first derivative evaluated at a, whatever value they give you. And then f double prime of a is second derivative evaluated at a, and so on until you get to f of n, okay? F to the n, and they'll also tell you what your n is. So this will be given as well. They'll say like, take the second Taylor polynomial, so then your n is 2, right? And you basically just have to stop here. Okay, because once you get to n is 2, so f to the second of a, then you're done. Okay, so all right. So now another thing that I'd like to point out. I'll go on to the next slide. We have something called Maclaurin polynomial. I'll just put poly. Maclaurin polynomial is basically just a specific case when your a is equal to 0. So it's centered at 0. And then this will just look like, we'll have f of 0, because a is 0, right? And then we have f prime 0 over 1 factorial. And then x minus 0 is just x to the 1. Plus, so this is just like a simpler version, I guess, a simpler, more specific version of the other Taylor polynomials. So then dot 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 up to fn of 0 over n factorial, and then x to the n. Okay, so that's just a specific case. Also, yeah. Alright, so let's actually do an example, because right now it's still probably a little bit confusing. So we'll do an example here. So we have, let's find the third Taylor polynomial, or I don't know how to term that, but this is what you'll see basically. So we're trying to find this centered at a equals 4, and then our f of x is x to the 5 halves. Okay? So we're trying to find t3. So our n equals 3. That's what this tells us. So, alright, let's set it up here. So t3x, I'm just going to write in the variables right now. So we have f of a, first of all, right? You always start with f of a, plus f prime of a. So there's a pattern here. Over 1 factorial. This is just going to be 1. X minus a to the 1. And then f double prime of a over 2 factorial. That's just going to be 2. X minus a to the second. And we have to go one more, right, for our n to be 3. So f to the third, and then of a, equals, or over 3 factorial times x minus a to the third. And now we're done, because according to the formula, our n equals 3 here, and we can stop, okay? So, the tricky thing now, because we know our a is 4, so we can just plug in a wherever we see it. We're just going to leave the x's. That's going to be in our final formula. Now our problem is finding the f of a, f prime of a, f double prime of a, and f triple prime. So let's derive some stuff. So we have our f of x. That's our original function. And then we need the first derivative. So that's going to be 5 over 2 x to the 3 halves. Okay. And then we need our second derivative. We need to go all the way up to the third derivative. So this is going to be 15 over 4 x to the 1 half. And then f triple prime, we're going to do one more here. That's going to be 15 over 8 and x to the negative 1 over 2. Okay, so now we don't just need these. We need them evaluated at at our a value, right? So I'll start with the original one. We're going to find f of a. So that's going to be f of 4, right? Because we know our a equals 4 here. Okay, so f of 4 is equal to 4 to the 5 over 2, which is equal to 32, because square root of 4 is 2, 2 to the 5th is 32. So we have our f of a, that's good. Now we need f prime of a. So f prime of 4 is going to be 5 over 2 times 4 to the 3 halves, which is equal to 20. F double prime of 4, okay, that's going to be 15 over 4 times 4 to the 1 half, which is equal to 15 over 2. And lastly, we have f triple prime of 4. It's equal to 15 over 8 times 1 over the square root of 4, right? Okay, so this last one is going to be 15 over 16. Alright, so here are our 4 important values, basically. So we're going to plug these in their corresponding spots. Okay, and I'll do that on the next slide. So we're going to get t3x equals, and let's plug them in. So for our first one, f of a equals 32, and then we have plus f prime of a, which was 20, over 1 factorial, which is just 1. And then we have x minus a, which is now 4, to the 1. And then we have that added to 15 over 2. Okay. And that was over 2 factorial. So that's over 2. So we could just say it's like times 1 over 2, right? And then times x minus 4 to the second. And then one more, we have our 15 over 16. And this was divided by the 3 factorial, so that would be divided by 1 over 6, or multiplied times 1 over 6, and then x minus 4 to the 3rd. So let's just simplify, and our final answer is going to be 32 plus 20 times x minus 4 plus 15 over 4, x minus 4 squared, plus, and then this simplifies down to 5 over 32, and then times x minus 4 to the 3rd. Okay, so this is our final answer. This is the third Taylor polynomial for our given function and our given a. Okay?